NEC 110.58 mandates a disconnecting means for transformers. This disconnecting means must be a switch or a circuit breaker. This switch or circuit breaker must simultaneously open all ungrounded conductors of the circuit. The location of this switch or circuit breaker must be within sight of the transformer. Additionally, the ampere rating of the switch or circuit breaker must not be less than the ampacity of the transformer supply conductors. This requirement ensures that the transformer can be safely isolated from the power supply for maintenance or in case of a fault. The term within sight generally means visible and not more than 50 feet away. This distance allows for quick and easy access to the disconnecting means. The ampacity of the transformer supply conductors is determined by the transformer's kVA rating and voltage. Calculations must be performed to ensure the correct conductor size and disconnect rating are selected. Using a disconnect with an ampere rating lower than the ampacity of the supply conductors would be a violation of the NEC and could create a safety hazard. For example, consider a transformer with a kVA rating of 75 kVA and a primary voltage of 480 volts. To calculate the primary current, the following formula is used. Primary current equals kVA times 1000 divided by the square root of 3 times the voltage. In this case, the primary current would be 75 times 1000 divided by the square root of 3 times 480, which equals approximately 90.2 amps. Therefore, the disconnecting means for this transformer must have an ampere rating of at least 90.2 amps. The conductors supplying the transformer must also have an ampacity of at least 90.2 amps after any applicable dirting factors are applied. Common disconnect types include fused disconnect switches and circuit breakers. Fused disconnect switches provide both overcurrent protection and a disconnecting means. Circuit breakers provide overcurrent protection and can also serve as the disconnecting means. When selecting a disconnect, it is important to consider the available fault current at the transformer location. The disconnect must have a suitable interrupting rating to safely interrupt any potential fault current. This interrupting rating is typically expressed in amps. Consult manufacturer's datasheets and conduct a short circuit study to determine the available fault current. Installing a disconnect that is not properly rated for the available fault current could result in equipment failure and potential safety hazards. The NEC also addresses specific requirements for transformer overcurrent protection in Article 450. These requirements specify the maximum overcurrent protection device rating based on the transformer's impedance. The overcurrent protection device is intended to protect the transformer from overload and short-circuit conditions. It is important to coordinate the overcurrent protection device with the disconnecting means to ensure proper operation. For example, if the overcurrent protection device trips due to an overload, the disconnecting means can be used to safely isolate the transformer for troubleshooting and repair. In addition to the general requirements of NEC 110.58, there may be additional requirements based on the specific application. For example, if the transformer is located in a hazardous location, additional requirements may apply, as outlined in Article 500 of the NEC. These requirements may include the use of explosion-proof enclosures and intrinsically safe wiring methods. Furthermore, the NEC requires that all electrical equipment be installed in a neat and workmanlike manner, according to NEC 110.12. This includes properly supporting and securing the disconnecting means and associated wiring. All electrical connections must be made using approved methods and materials. The disconnecting means must be readily accessible for operation and maintenance. Obstructions that could prevent access to the disconnect must be removed. Proper labeling is also essential. The disconnecting means must be clearly labeled to indicate the equipment it serves. This labeling helps to prevent accidental disconnection of critical equipment. The labeling should be durable and easily readable. In addition to the NEC requirements, local codes and regulations may also apply. It is important to consult with the local authority having jurisdiction, often referred to as the AHA, to determine any additional requirements. The AHA has the final authority on the interpretation and enforcement of the NEC. Regular inspection and maintenance of the disconnecting means are crucial for ensuring its continued reliability. The disconnecting means should be visually inspected for any signs of damage or deterioration. All electrical connections should be checked for tightness. The operating mechanism should be tested to ensure it functions properly. Any necessary repairs or replacement should be made promptly. Proper grounding is also essential for electrical safety. The disconnecting means must be properly grounded according to NEC Article 250. This grounding helps to prevent electrical shock hazards and ensures proper operation of overcurrent protection devices. The grounding conductor must be sized according to the requirements of the NEC. When working on electrical equipment, always follow safe work practices. Energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. Verify that the circuit is de-energized using a voltage tester before touching any electrical conductors. If you are not qualified to work on electrical equipment, consult a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or property damage. To reiterate, NEC 110.58 explicitly requires a disconnecting means for transformers. There are no exceptions to this requirement in the general case. The disconnecting means must meet specific criteria, including being within sight of the transformer, having an adequate ampere rating, and simultaneously opening all ungrounded conductors. Failure to comply with these requirements is a violation of the NEC and can create significant safety hazards. Remember to always consult the latest edition of the NEC for the most up-to-date requirements. Electrical codes are subject to change, and it is important to stay informed of any revisions or updates. Continuously reviewing and understanding the NEC is crucial for ensuring electrical safety and compliance. Consider the scenario of a large industrial facility with numerous transformers supplying power to various loads. Each of these transformers must have a properly sized and installed disconnecting means. Regular inspections should be conducted to verify the condition and functionality of these disconnects. A comprehensive maintenance program should be in place to address any identified issues promptly. This proactive approach helps to minimize the risk of electrical failures and ensures the safety of personnel and equipment. Furthermore, proper documentation is essential. Maintain accurate records of all electrical installations, including transformer disconnects. This documentation should include details such as the disconnect rating, conductor size, and installation date. This information can be valuable for troubleshooting and future maintenance activities. Consider a step-down transformer used to supply power to sensitive electronic equipment. In this case, a high-quality disconnecting means may be required to minimize voltage transients during switching operations. A surge protective device, sometimes referred to as an SPD, can be installed in conjunction with the disconnecting means to protect the electronic equipment from voltage surges. This combination of devices provides enhanced protection and ensures the reliable operation of the sensitive equipment. When designing an electrical system, always consider the specific requirements of the application. Factors such as the load characteristics, environmental conditions, and safety requirements should be taken into account. A well-designed electrical system will provide reliable power and minimize the risk of electrical hazards. Continuous education and training are essential for electrical professionals. Staying up to date on the latest codes, standards, and technologies is crucial for providing safe and effective electrical services. Participate in training programs and attend industry events to expand your knowledge and skills. By investing in your professional development, you can contribute to a safer and more reliable electrical infrastructure. In summary, the NEC 110.58 clearly mandates a disconnecting means for transformers. This requirement is not optional and must be strictly adhered to. The disconnecting means must be properly sized, installed, and maintained to ensure electrical safety and compliance. Always consult the latest edition of the NEC and any applicable local codes to ensure that your electrical installations meet all requirements. Remember, electrical safety is paramount. Take the time to understand and follow the applicable codes and standards. By doing so, you can help to prevent electrical accidents and protect yourself and others from harm. Think of a situation where a transformer needs to be de-energized for maintenance. The disconnecting means allows qualified personnel to safely isolate the transformer from the power source. This prevents the risk of electric shock and allows the maintenance work to be performed safely. Without a disconnecting means, it would be difficult and dangerous to de-energize the transformer. The disconnecting means is a critical safety feature that protects workers and equipment. Consider the specific requirements for labeling the disconnecting means. The label should clearly identify the equipment that the disconnect serves. This helps to prevent accidental disconnection of critical equipment. The label should be durable and easily readable, even in dimly lit environments. Proper labeling is an important part of a comprehensive electrical safety program. The NEC also addresses the requirements for working space around electrical equipment in NEC 110.56. Adequate working space is essential for safe operation and maintenance of electrical equipment, including transformer disconnects. The working space must be clear of obstructions and provide sufficient room for personnel to perform their tasks safely. Compliance with the working space requirements is critical for preventing electrical accidents. When selecting a disconnecting means, consider the environmental conditions. If the disconnect is located in a wet or corrosive environment, an M4X enclosure may be required. This type of enclosure provides protection against water, dust, and corrosion. Selecting the appropriate enclosure is essential for ensuring the long-term reliability of the disconnecting means. Remember that the disconnecting means is not only a safety device, but also a critical component of the electrical system. A properly selected and installed disconnecting means will contribute to the overall reliability and performance of the electrical system. Take the time to carefully consider the requirements of the application and select a disconnecting means that meets those requirements. In addition to the NEC requirements, consider industry best practices. Consult with experienced electrical professionals and learn from their expertise. Attend industry conferences and workshops to stay up to date on the latest trends and technologies. By embracing industry best practices, you can improve the safety and reliability of your electrical systems. When performing electrical work, always use the proper tools and equipment. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment such as safety glasses and gloves. Follow safe work practices and never take shortcuts. Electrical safety is a serious matter and should always be treated with respect. Consider the scenario of a transformer failure. The disconnecting means can be used to quickly and safely isolate the faulty transformer from the rest of the electrical system. This prevents further damage and allows for repairs to be made. The disconnecting means is an essential part of a comprehensive electrical protection strategy. Remember that the disconnecting means is not a substitute for proper overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses are designed to protect the transformer from overload and short-circuit conditions. The disconnecting means is intended to provide a means of isolating the transformer for maintenance or in case of a fault. The two devices work together to provide complete protection. When installing a disconnecting means, be sure to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation and operation of the device. Following the manufacturer's instructions is essential for ensuring the device performs as intended. Remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes and revisions. Subscribe to industry publications and attend training programs to keep your knowledge current. By staying informed, you can ensure that your electrical installations meet all applicable requirements. In conclusion, the NEC 110.58 clearly requires a disconnecting means for transformers. This requirement is not optional and must be strictly adhered to. The disconnecting means must be properly sized, installed, and maintained to ensure electrical safety and compliance. Always consult the latest edition of the NEC and any applicable local codes to ensure that your electrical installations meet all requirements. Electrical safety is a shared responsibility. Everyone who works with electrical equipment has a responsibility to follow safe work practices and comply with applicable codes and standards. By working together, we can create a safer electrical environment for everyone.